All right, so in this video, we're going to learn how to predict the solubility of ionic compounds in water. So that's going to be the idea for this. So let me write that. Solubility of ionic compounds, water solubility. Water solubility of ionic compounds. Okay, so and then this method works most of the time, but there are exceptions always. Okay, so to predict the water solubility of ionic compounds, we're gonna use the ionic force again. Okay, so the idea is stronger the ionic force or stronger the ionic interactions between the cation and the anions in an ionic compound, less likely for it to be soluble in water. So that's going to be the idea. Okay, so now how to use this? So what we're going to do is we're going to have a sort of a rule. Okay, let me say the rule is the charge product. Okay, so everybody knows the charge product is charge of the cation times the charge of the anion, and then we only care about the absolute value of this. Okay, so we can focus on only the absolute value of this. The idea is this: if the charge product is greater than or equal to 4, then your ionic compound is insoluble in water. Insoluble in water. Okay, on the other hand, if the absolute value of the charge product, cation times the anion charge, is less than 4, then it's going to be, we can predict it to be soluble in water. Okay, so this is just to predict the solubility of ionic compounds. Okay, of course there are exceptions to this rule, but most of the time this works. I'll give you an example. Okay, so let's think about something like calcium oxide. Okay, so calcium oxide is this. Okay, and then in calcium oxide, if you look at the charges, calcium is +2, oxygen is -2. Therefore, the charge product, cation times anions, and anion charge is going to be equal to 4. Okay, since it's equal to 4, I mean, we can predict this to be insoluble in water. Insoluble in water. Okay, on the other hand, let's take another one. Let's take calcium chloride. Calcium chloride. Okay, CaCl2. Again, if you write the charges, calcium is +2, chlorine is -1. Okay, so we only care about the charge of one ion. Okay, because when the ions interact, we're talking about the interaction between one cation and one anion. That's the idea. So that's why we wrote -1, not -1, not -2, because we have 2 of them. So we only write the charge of one anion and one cation. Anyway, so this gives a charge product of 2, which is less than 4. So based on the second line of the second line over here, all right, we know that it's going to be soluble in water. Okay, so let's do another one, and then let's think about say sodium oxide or sodium sulfide, Na2S. Okay, again, sodium is +1, sulfur is -2. The charge product is -2. The absolute value of the charge product is 2. Okay, since this is less than 4, we can predict this to be soluble in water. Okay, and then if you think about another one, the last one maybe, so let's think about aluminum, uh, say aluminum oxide or aluminum sulfide, Al2S3. Okay, again, if you write the charges out, aluminum is +3, sulfur is -2. Therefore, the charge product here is +3 times -2 is -6. Absolute value should be 6, which is greater than 4. Therefore, this is going to be insoluble in water. Okay. Yeah, I think that's it. That, I mean, we can use this to predict the water solubility of ionic compounds. Okay. All right. I hope this helped. And then I'll see you in class. Bye, everybody.